If you look at the periodic table, as we've talked about before, we can predict the charges that if the element became an ion, that we could say that they have particular charges, such as +1, +2, +3, -3, -2, -1, and of course the noble gases are 0. Now what about the elements in the middle? Now those elements actually have more than one charge, and so we have to treat those special. And so for instance, iron is +2, +3, and cobalt's +2, +3, nickel's +2, +3, and then you get to copper, and that's +1, +2, and as mentioned in a previous video, these guys in this triangle over here, silver's always +1, and zinc and cadmium is always +2. So we don't know ahead of time what charges are going to be in the middle. Now we do know the other elements, we go +1, +2, +3, -3, -2, -1, but the middle elements, it's not as easy. And so what we need to be able to do is we need to be able to determine what the charge is on the element, because this is going to become very important when it comes time to name the element. Naming is what makes this more difficult than, say, some other things. Okay, and so this is a key skill, determining the charge on an element. Now, how does this work? And so let's say we have these two iron compounds. And we'll get into naming later. But first off, to be able to name these things, we have to be able to determine the charges. Now, these are both iron oxide compounds. You have iron, you have oxygen, but they're very different. The formulas are very different, and the compounds are very different. This is rust-colored, the first one. And this one is kind of a dark green. Okay, and they have completely different chemical properties. So our goal here is to determine the charge on the iron, on the metal. Because if we go back and look at the periodic table, iron is in the middle of the periodic table. It's Fe, and it's right over here. And iron comes in two flavors. It's either +2 or +3. And we have to decide, well, what is that iron going to be? And so we have two compounds with iron right here. Now, what we do is we take the piece that you know, and you use that to determine the piece that you don't know. Okay, so we're looking for the charge on the iron. Now, what do I know over here? I know oxygen is O2 minus. I know that. This is the piece that I know. How do I know that? Let's go back to the periodic table, and you look over here, and what do you see for oxygen? It's in the -2 column. Everybody is -2 in that column. We don't know what iron is. It could be +2 or +3. And so we're going to figure out what is the iron. Okay, now remember the one thing that's true of ionic compounds, the metal with a nonmetal, the one thing that's true is that the total must equal 0. The total charge must equal 0. Okay, so we know that's true with ionic compounds. So look, there's oxygen, and I know it's 2 minus. And how many of the oxygens do I have? I have 3 oxygens. So I say, you know what? It's 3 times minus 2 gives me minus 6. So there's minus 6 on those 3 oxygens altogether. Each one is minus 2. There's 3 of them. So we do know that it has to equal 0 for all of them. So what do you have to have for the irons? Well, the only thing that's going to give you 0 is plus 6, because 6 minus 6 is 0. But look here. You have 2 irons. So what does each iron have to be to add up to 6? Well, if you have 2 of them and the total is 6, then each iron must be 3. Each iron must be 3, because what's 2 times 3? That's 6. And so each iron, and there's 2 of them, must be 3. And that gives you plus 6, and that adds up to 0. So the iron, in this case, the 2 pieces of this compound must be iron 3 plus and oxygen 2 minus. So I've determined that the charge on that iron must be 3 plus, because that's the only way that we're going to get the 2 pieces to add up to 0. You have 2 times 3 minus 3 times 2. That gives you 0. Now, if we look over here at the iron with the 1 oxygen, it's the same situation. Now we have, I know for a fact that the oxygen is 2 minus over here. How do I know that? Well, we go back to our periodic table like we just did a moment ago, and you see the oxygen is under the minus 2. And so I know that the oxygen must be 2 minus. The iron I don't know. But if this is 2 minus over here, and the total has to equal 0, what does the iron have to be? Well, the iron has to be plus 2. And since there's just one of them, that's the charge on that iron. So the iron has to be 2 plus, because 2 minus 2 equals 0. Now, another way of looking at this, though, if you want to really think about this, is if you have 2 different numbers, such as this, the numbers themselves, the subscripts, which tells you how many irons, how many oxygens you have, came from crossing the charges. So you can uncross the charges so that you can tell, what happened here. So I uncross the charges. And so once again, we determined that the iron in the iron oxide here with the subscript 2 and subscript 3 has to be 3 plus. Now, there's a problem with that, though. You can't use that uncrossing for a situation like this, because we don't know. It could be 2 and 2, it could be 1 and 1, it could be 3 and 3. Remember, when we have these empirical formulas, we're always going for the lowest possible number. So you don't want to uncross if they're different, if they're the same. So don't uncross if 1 and 1. Okay? So 1 and 1, we don't know. In that case, you definitely have to go and say, well, that's 2 minus. Then to add up to 0, this has to be 2 plus. Okay? So uncrossing works if the numbers are different. If they're different, go for it. Just uncross it. The safest way to do things is to look at what's on the piece that you know, the oxygen, and figure out the piece that you don't know. right, so let's take a look at another one. Let's say we have some copper with, say, sulfur. And we have these two right here. And copper is another one of those elements that we take a look at the periodic table. And it's another one of these elements over here that has more than one charge. It's +1 or +2. That's how copper comes. It comes in two flavors. It's either has a +1 charge or a +2 charge. And so once again, we have to figure out what's the charge on the copper. Now we could uncross the charges on the first one. And if we do that, then we have 2 minus over here. And since there's an implied 1, we have a plus over here. And since there's 2 of them, that gives you +2. And then the sulfur, there's 1 of them at -2. That gives you 0. So in this case, I just went ahead and uncrossed the charges. Now, a better way that's maybe takes a little bit more time would be to say, okay, what do we have here? We're trying to determine the copper, and we look at the periodic table, and sure enough, it's one of those. But where's sulfur? Sulfur is right here, and it's underneath the -2 column. So I know sulfur must be -2. And so we look over here and we say 2 minus on the sulfur. And we know the total has to equal 0. And so we must have 2 plus over here on the copper, because 2 minus 2 is 0. But what do we have here? We have 2 coppers, and the 2 of them have to add up to 2 plus. And so that means the copper has to be +1, because 2 of them times +1 gives me +2. And then we can add that in once again to get 0, since there's 2 coppers right over here. And so the math still works out either way. Now let's take a look at the other copper sulfide compound. And we see that they're 1 and 1, so we can't uncross the charges. And so since we can't uncross the charges, we have to decide what we have here. But I do know that sulfur, since we just looked at the periodic table, I do know the sulfur's 2 minus. And I do also know that any ionic compound charge has to add up to 0. And so I know that this must be 2 plus, because 2 minus 2 gives me 0. And so this is copper 2 plus with the sulfur 2 minus. And so by doing it this way, we can make sure that the charges add up to 0. So that's how you do variable charges with our transition elements. And by the way, it's not just the transition elements. All of these over here that are not transition elements, they also can have variable charges, and they do. And they have a special name. And these are what are called the poor metals. And the poor metals in that area can have various charges as well, but it doesn't change what you're doing as far as trying to figure out what the charge is. Okay, so now that's how you do that. Now we have another kind of ionic compound, and that's involving something called polyatomic ions. Now there's a table in your book that you need to memorize. Okay, now there's no way around it. The polyatomic ions are what are called covalently bonded molecules with a net charge. Now, so far, what we've been dealing with are things like atoms like sodium plus, chloride minus, sulfur 2 minus, which we just did. Those are atoms. Polyatomics, on the other hand, look like this. That's a polyatomic ion. This is a molecule with a net charge. And they have, and we have to memorize that list. And this one, just to say the name, because we're going to do naming very shortly, this is called the nitrate ion. And we have others, like this one. This is called a phosphate ion. And there's a list of them. It's something like 22 different polyatomic ions. Some of them are used a lot more than others, and some are not as much as others. And we have some more common ones, like this one. This is the sulfate ion, and so forth. Now, when we're using these to make molecules, the same rules apply. The total charge has to equal 0 when we put them together in an ionic compound. The charge has to equal 0. Now, there's a couple things you have to be aware of, though. This PO4, this NO3, you can't change what it is. It's an NO3. If you change it to something else like NO2 or NO4 or NO, it's not the same molecule anymore. So let's take a look at what we have to do to write the appropriate formula between a polyatomic ion and something else. So let's take a look at, say, sodium ion and nitrate ion. Now, once again, when we're going to make an ionic compound, the charge has to add up to 0. Now, this negative charge over here, I'm going to circle this negative charge, is on the entire molecule. It's not on the oxygen, not just on the oxygen. And that's important. It's important because we're trying to get the charges to balance. We're trying to get the charges to add up to 0. Okay, it's not just on the oxygen, it's on the entire molecule. And so if we want to make this compound, which by the way is called sodium nitrate, pardon me, we'll go ahead and push them together, just like we did with the other compounds. Okay, and I just pushed them together. And we have to make sure they add up to 0. Does it add up to 0? And the answer is, well, yes, they do, because we have 1 minus 1, which equals 0. So far, so good. And so we have an ionic compound. It's composed of ions. It has a cation, the sodium. It has an anion, the nitrate. And they do add up to 0. And so that's good. This is good. So nothing spectacular so far, but what do we do if we have something where the charges don't add up to 0? What do we do then? So let's say we had calcium ion, which we know is 2 plus. We look at our periodic table and we pull one up and we look at our periodic table and we see calcium. Where's calcium? It's in the +2 column. Since we have that pattern, +1, +2, +3, -3, -2, -1, and 0, we have that pattern. And so we know calcium's 2 plus. But let's pair it up with, say, another nitrate. Nitrate's used a lot. If you've looked at drugs, drugs, a lot of drugs, they say like Bralar nitrate, and it's because the nitrates help make them blood soluble. And so we have 2 plus on the calcium, and we have a -1 on the nitrate. Now what do we do? Well, if we just push it together, what are we going to get? We're going to get a calcium with the nitrate. Okay, keeping in mind, we don't write down the charges when we push them together. But if we say 2 minus 1, we have what? We have +1, and that's bad. We need the charges to add up to 0. So once again, we're going to do crossing the charges. Now, remember, there's an implied 1 over here, but we never write down the 1. And so we're going to cross the 1. And we're not going to put the 1 down there, but just to show you that there is a 1 there, there is a 1. But we don't actually write that down, because as long as you have 1 there, we know there's as long as you have a calcium there, as long as you have one thing, we know there's one thing there. We don't have to put a 1 down. Now, what to do about this 2, on the other hand? What are we going to do about this 2 when we cross the charges? Now, remember, that -1 is on the entire NO3. We can't just say it's on the oxygen. It's not just on the oxygen. So what we're going to do is we're going to say all of the nitrate, we're going to put a 2 on it. There's the 2. So we're putting, since we're saying the -1 is on the entire NO3, we have to show that it's a whole molecule that's counting for the charge. And so the way we're going to show that is we're going to put it in parentheses. We're going to put that polyatomic in parentheses if we have more than one of them. So what I don't want you to do, and I see people do this all the time, don't do this. I see this all the time where they'll say, well, there's 2 of them, it must be, and they say 6. Don't do that. Okay? Don't do that. And also, I've also seen where folks do this. They say, oh, well, I need to change the oxygen to match up. Do you see what I just did here, where I took the 2 and I changed that 3 to 2? And that's changing it to something else. The NO2 is not an NO3. Don't do that. Okay, so what we're doing is we're crossing the charges just like we did with just the elements. Like when we did, say, like aluminum and oxygen, we crossed the charges in that case as well, but we didn't have to put it in parentheses because there was just one thing. It's understood that 3 goes on to the oxygen. So we have to be very careful to make sure that we put those polyatomics, if there's more than one, because back over here, there was only one NO3 nitrate ion. And so we didn't have to put it in parentheses. So I don't want you putting this in parentheses just because. No, don't do that, okay? Don't do that. It's okay as it is to just leave it by itself like that. And so we have to make sure that if there's more than one, we put it in parentheses. So let me show you another example here. Okay? And so how about we have, say, how about barium, which is a 2 plus, and let's say we have a phosphate ion. You need to memorize these polyatomics and out of your book. There's a table in your book to memorize the names and the charges and the formula for each of the polyatomics. But here's a phosphate ion with a barium ion. And I know barium is a 2 plus because I look at my periodic table, and barium is way down over here. There's barium, and it's in the 2 plus column because it goes +1 +2 +3 -3 -2 -1. And there it is. And the phosphate ion, I know it's a PO43- because I've memorized my list of polyatomics. And so once again, we're going to cross the charges. And so we're going to go ahead and push these guys together, and we have that. And remember, we don't bring down the charges on our finished product here. We're trying to figure out how much each one we have. And so once again, we're going to go ahead and cross the charges. Well, the 3 on the phosphate is going to cross over to the barium. But we also have to take care of the 2 on the barium, and it's going to cross over to the phosphate. But a phosphate is a polyatomic ion. And remember, we don't want to change what it is. We just want to say, how many do we have? So we put that in parentheses, and we put the 2 down there on the corner. And once again, the charges have to add up to 0, and that's why we're doing this. And if you take that barium, well, there's 3 of them now. The charge on each one of those bariums was +2. That gives me +6. And the phosphate, well, there was 2 of them, and the charge on each phosphate, not on the oxygens, on the whole thing, is -3. And 2 times -3 gives you -6, and that gives you 0. So once again, we're happy. We've got the charges to add up to 0. And so I'm going to show you one more thing here, a useful exercise that you can do on your own is to make a table, just so you can practice doing crossing charges. And you could say like chlorine minus, let's say N3 minus, and maybe we can go with a polyatomic sulfate 2 minus, and then you can run down the left side and you could say like sodium plus barium 2 plus, and maybe even aluminum 3 plus. And you can practice making the appropriate compound. And this is also something that we're going to do later on with naming, is you just make yourself a table like this, or you can actually download worksheets off the internet and practice those as well. The worksheets are great off Google. They come with the answers. And so the more you practice, the better you get at this. And so we go ahead and, we're going to pair these up and cross charges. So the sodium goes with the chloride. Well, they're already equal, so we can do that. Sodium with N3 minus, the nitride ion. And so the 3 comes down on the sodium, and the 1 goes over on the nitrogen. And we're working our way across, so the 2 on the sulfate ion comes down on the sodium. I hope you can see, how the charges are going to cross. It's a little bit different the way I have it laid out, but you can see how the 2 comes down on the sodium and the 1 on the sodium comes down on the sulfate. Now let's take a look at the barium row, barium 2 plus, and so the 2 is going to cross down onto the chloride for the barium chloride. And so the 3 off the nitrogen crosses down onto the barium, and the 2 off the barium crosses down on the nitride, the nitrogen. And the 2 on the barium and the 2 on the sulfate, well, they're already equal to 0, so we just go ahead and push those together. And now we have our barium sulfate there. More on naming later. But it's good that you go ahead and say the names if you know the names. And then finally on this last row, we see the 3 is going to cross down onto the chlorine or the chloride, and the 1 goes down on the chlorine on the aluminum, so that becomes aluminum chloride. The 3 on the aluminum, the 3 on the nitride are already equal, so we just go ahead and push them together. ALN, aluminum nitride. And then we have to cross the 2 onto the aluminum, and the 3 crosses on the sulfate. And remember, sulfate SO4 is a polyatomic, so we have to put it in parentheses, and we put a 3 down there. And so this is a useful exercise. If we were doing this in person, I would make everybody go up on the board and do this um, in person. And so that's how you have to do that. And so practice makes perfect. But the big thing here is that when you're making a compound, an ionic compound, which has anions and cations, you have to make sure that the charges add up to 0. And if the charges don't add up to 0, then what we have to do is we do crossing of the charges. And the big thing here for today is if you have a polyatomic, you must put it in parentheses if you have more than one of them.